So I've been doing Scala for a little while. My talk today is a pretty basic talk. It's oriented at beginners, so if you get bored, I won't be offended if you start yawning. But it'll also be a pretty quick talk, so you won't be bored for long. Basically, what I want to talk about is using types in a basic use case that most people will probably be doing at some point in time, and how it can improve the way your code reads and the way your code is used by others. So the scenario that we're going to start with is we've developed an API. It's a basic RESTful API. It has one operation. You have a delete. You can pass in some query parameters, and you get some sort of result back. The result can be a success, in which case you get a status saying success and a list of users. So presuming that this delete API deletes users. The operation can also fail, in which case you get a status of failure, and you'll have some sort of reason as to why it failed. Now, this is a basic API. Once it's built, you could easily just throw it to your customers and throw it to your consumers and let them use it. But we want to build a library for it to make it a bit easier to use, a little bit more user-friendly, hopefully gain some adoption. And we don't really care about our library at this point, and so we're going to make it in a pretty poor manner. So we think about, what does this library need to do? Well, it needs to parse the result of our API call and expose that to the program to do as they want with it. So we define some case classes to represent our results, one of which is the result, which has a status, success or failure, a list of users, and a reason. So that's everything that we get back from our APIs. We also have a user case class, which has an email and a name. OK, so we've built this thing. We don't really care about it. And we need to decode our JSON to actually populate these objects. I won't go into too much detail about this. This is Argonaut. The implementation of this doesn't really matter, but what we're essentially saying is we're decoding our JSON and attempting to put it into our result data object, or putting a null there if it doesn't exist. And we all love nulls, right? You can put them in anywhere, and no pesky compile time failures. Can worry about that later. So we've built this API, we've built this library, and we start giving it out to our consumers. So someone picks up the library and thinks, OK, I'm just going to look at what methods I have and start using things. And what they get back is a case class result that has a status, user, and reason, as we saw before. And I think, OK, that's cool. I can start using that. So I'll call my delete and then start using my result that I've got back. And I start to log it. Take the result and the status, convert it to uppercase, the reason, convert it to uppercase, and go through each of the users and log all this stuff. And the result of that would be null pointer exceptions all over the place, because most of these things, or some of these things, won't exist on each result. There is no way for me to tell that based on my type, though, because according to what I see there, I should have a status, I should have a list of users, I should have a string. None of this should fail, but I've started putting nulls in everywhere, and so things explode at an inconvenient time. And there's no way for me to know that without actually understanding the way my API works. That's not something we want our consumers to have to worry about. Ideally, what we would do is only expose the information that they need to know. So our consumers are annoyed, and they come back to us and say, make a better library. So we think, OK, how can we improve this? Well, Scala has options. Even Java has optionals. Maybe we can use those to improve this. Let's give it a try. We changed the implementation of our case classes to now have options in places where we think attributes may not be. For example, we won't have a failure reason when we succeed, so we make that an option of a string. We won't have users when we fail, so we make that an option of list of users. Our user doesn't always have a name. Based on our API, we always have an email, though, so we make that an optional too. Then we try to use this. It's kind of better. Now we don't have any null pointer exceptions, though our code becomes a little more ugly, because now we have to map or for each or get or else on a bunch of things. when in reality, this result doesn't represent the result of our API. Because according to our type, we could have no users and no failure reason. But if we go back to our definition, we'll always have either a list of users, which may be an empty list, or a failure reason. So we're forcing our consumer of our API to handle a case that doesn't actually exist, which means their code gets more complex and less maintainable. And again, we wouldn't be able to tell, our consumer wouldn't be able to tell this from the types, because according to what we've defined, they're just options. There's no relation between the two of them. So it's a bit safer, but it isn't really more usable. Slightly better. Can we do it any better than that? Probably. Let's see. Instead of having a catch-all result object, let's make our result a trait. Our trait has a status of string, because we know our API always returns a status. And it either has a success case class that extends that result, or a failure class that extends that result. And in our success class, we will always have a list of users. And in our fail class, we will always have a failure reason. Our user class remains unchanged because we may or may not have a name for our user. The usage of this means that our consumer doesn't have to care about our API at all. They just need to look at the types that we produce, and they can understand exactly what can come out of our API. So now when using it, we don't attempt to map when we don't need to. We just do a pattern match. When we get a success, we will always have a status and a list of users. When we have a failure, we will always have a status and a failure reason. This gives us compile time checking of things that we care about, and allows our user to not have to worry about things that don't concern him. He can look at our API, he can look at the objects we produce, and understand immediately what to do with it. And yeah, so the too long didn't read of that is that if we use types to represent the state of our program, we can improve the readability of our code. States which cannot be reached in our code should not be representable by the type system. By doing this, we avoid people having to handle situations that never actually exist. And if we handle all these concerns at the borders of our program, it makes it easier on the once it's handled, essentially. You don't have to worry. You worry about it once and not again. And yeah, that's my quick talk on types. Hopefully it helps someone.